In this video, let's verify the stability and causality of the system. Determine whether the following system represented by input-output relation is stable and causal. Here three systems are given. We are supposed to calculate whether these systems are stable and causal. Let me consider the first example. That is the input-output relation is given by y of n is equal to, we have x of n plus 1 plus x of n plus x of n minus 1. So before proceeding with this example, let me recall few relations between x of n and delta function. We know that x of n convolution with delta n is always equal to x of n, and another relation is x of n is convolution with delta of n minus n naught is always equal to x of n minus n naught. So one should remember these two rules so that we can easily simplify this example. So now let me make use of these relations. I can represent this y of n as y of n is equal to, so here the term is x of n plus 1. So I will represent this in terms of impulse signal as x of n star delta of n plus 1, because here we can see that x of n star delta of n minus n naught is same as x of n minus n naught. So here delta of n plus 1 star x of n is same as x of n plus 1. Similarly, for this I can write it as x of n star delta of n, because x of n star delta of n is same as x of n, plus this I will represent it as x of n star delta of n minus 1. So therefore I can rewrite this y of n as y of n is equal to x of n star, we have delta of n plus 1 plus delta of n plus delta of n minus 1. So now let me consider this as the impulse signal, that is h of n. So therefore h of n is equal to delta of n plus 1 plus delta of n plus delta of n minus 1. Let me draw this h of n signal here. So say this is h of n. At n equal to 0, the magnitude is 1 here. At n equal to 1, that is at n equal to 1, the magnitude is 1. And at n equal to minus 1, the magnitude is 1. This is the h of n signal. Now we'll verify whether h of n is stable and causal. So we know that h of n is said to be causal, that is h of n is equal to 0 for n less than 0, then system is causal. But here we can see that h of n exists for n equal to minus 1. Therefore here h of n is not equal to 0 for n less than 0. Therefore this system is non-causal, because the condition is h of n must be 0 for n less than 0. Then only we can say that system is causal. But here for n equal to minus 1, the system has got value 1. Therefore this is non-causal signal. Now let me verify whether it is stable or not. We know that summation n is equal to minus infinity to infinity h of n. If it is less than infinity, then system is stable. This is the condition for stability. Now we will verify the same with respect to the given system. That is, here the n varies from minus 1 to 1, that is minus 1 to 1. We have h of n is equal to, so the values are 1. At n equal to minus 1, it is, I can expand this. We have h of minus 1 plus h of 0 plus h of 1, which is equal to 1 plus 1 plus 1, which is equal to 3. So 3 is less than infinity, or h of n is summable. Therefore, system is stable. So this system is non-causal, but it is stable. Now let me take the second example, that is y of n is equal to 2x of n plus 1 plus 3x of n minus x of n minus 1. So I will rewrite this expression in terms of impulse signal as y of n is equal to x of n star. I can represent it as 2 delta of n plus 1 plus we have 3 x of n star 3 delta of n minus, I can represent this as x of n star delta of n minus 1, or I can represent it as y of n is equal to x of n star, I'll take this as a common, 2 delta of n plus 1 plus 3 delta of n minus delta of n minus 1. So here I can say that this is the impulse response of the system, that is h of n. Therefore, impulse response of the system h of n is equal to 2 delta of n plus 1 plus 3 delta of n minus delta of n minus 1. Let me draw the signal so that we can understand better. So say this is h of n. So at n equal to 0, the magnitude is 3. Let this be 3. Now at n equal to 1, the magnitude is minus 1. At n equal to 1, magnitude is minus 1. Now at n equal to minus 1, the magnitude is 2. So this is 2. So here we can see that. So here h of n is not equal to 0 for n less than 0. Therefore, system is non-causal. Now we'll check whether it is stable or not. The condition for stability is summation n is equal to, here it varies from minus 1 to plus 1, h of n is equal to, we have n equal to minus 1, value is 2, at n equal to 0 it is 3, at n equal to 1 it is minus 1. So we are taking magnitude, we are supposed to consider it as plus 1, which is equal to 6, and 6 is less than infinity. That is, the system is absolutely summable. Absolutely summable. Therefore, system is stable. So this system also stable, but it is non-causal. Now let me consider an example. That is, here impulse signal is given directly. That is, h of n is equal to, we have minus 0.5 power n u of n. So let me draw this signal. Say this is h of n. It's a right sided signal because of u of n. At n equal to 0, the magnitude is 1. At n equal to 1, the magnitude is minus 0.5. That is minus 0.5. So at n equal to 2, it is minus 0.25. So here we can see that h of n exists only for n greater than or equal to 0. That is, h of n is equal to 0 for n less than 0. For n less than 0, its value is 0 here. Therefore, system is causal. We will verify the stability. That is, the condition is summation n is equal to minus infinity to infinity h of n. It must be absolutely summable, that is less than infinity. So in this case, summation n is equal to 0 to infinity, we have h of n. That is, summation n is equal to 0 to infinity, so which is equal to 0.5 power n, so which is equal to 1 upon 1 minus 0.5, which is equal to 2, which is less than infinity. Therefore system is stable. This is how we can verify the causality and stability for the given system. Thank you for watching.